Hello and welcome back to the lab. On the bench today, we have yet another vintage Hewlett-Packard Nixie tube digital voltmeter. This time it's the 3480B. In fact, we have two of them. Um, I purchased the top one, and the bottom one was thrown in as an extra parts unit free of charge. So I actually got a pretty good deal. Now the bottom one is missing some boards on the inside, and it's also missing a couple of the Nixie tubes. Um, so we're going to continue to use that as a parts unit, but we're going to try to restore this upper one. In fact, what we're going to try to do is combine the best parts of both of these units to complete one fully restored, fully functional HP 3480B digital voltmeter. I'm going to turn the upper one on to show you that it actually lights up and works just fine. The sample rate light blinks just fine. Let's add 10 volt voltage to it. And it does read 10 volts. You can change the polarity. It also reads -10, just fine. All the ranges work just fine. I've already checked it out. Now, the, if you leave the instrument on, this one on for more than about half an hour, it does develop some strange flaky problems with some of the digits here in the display. Um, so there will be an electrical repair I'm going to have to do on this. But right now it actually looks like it's working perfectly fine. Now mechanically, it's not in the best of shape. Cosmetically, there's some deep gouges on the top, a couple of dents. Um, the release latch is cracked and broken here for the plug-in part of the module. Um, in both of these units, the discoloration of the plastic part of the front panel is pretty severe. It's turned this ugly yellowish brown color. In fact, both front panels are supposed to be the same color as the knobs on these instruments. I think it's called mint gray or something like that. It's a very pale gray with a slight hint of olive green to it. Um, so I'm going to do the retrobrighting process to try to bring those discolorations back to their original color without doing any damage to the instrument. And hopefully I can do that to both of these front panels. So I'm going to take the best parts of both of these instruments and combine them into one fully functional um, restored unit as good as possible. Also, note that neither of them have the feet or the tilt stands. Um, so I'm using my universal tilt stand here, the big roll of solder. That's what we use as the universal tilt stand. I'm going to put feet and tilt stands on one of them, on the one that I decide to restore, which will probably be the upper one, because it seems to be working. The lower one is actually missing Nixies, and one of the A to D conversion boards inside is also missing. It's missing the front logo, and someone has used some strong detergent or a solvent or something and accidentally removed the white paint that actually indicates the model number. This can happen. And I have done this before. That's why I know it can happen. But I didn't do it on this particular one. I knew better than to do that at this point. The lower one also has some yellow paint on the handle here. I'm not sure why that would be, but someone decided that yellow school bus yellow paint would look really good for whatever reason. So I'll do have to clean that off, or I probably just will not use this instrument. This bottom one would probably just be a parts unit used for spare parts. So I'm going to now disassemble the both units, remove the front panels, and get them start the retrobrighting process to try to bleach them back to their original color. Let's get started on that now. Okay, so I've very carefully removed the front panel and both of the plastic latches, and I use a disposable paintbrush and some of this cream peroxide developer used for hair salons. Um, and I take my disposable paintbrush and take a little bit of that peroxide stuff and just carefully apply it to every inch of the plastic surface. And very carefully do that, making sure not to really miss any part of it. All along the top and all along the bottom and in all the little nooks and crannies to be sure we don't miss anything. I'm using some rubber gloves, by the way, because I don't really want to touch this stuff. It's not really good for you, of course. Um, and I'm going to do the same process for these little plastic latching clips, at least the parts that are exposed to the outside. You can hear some birds chirping and some sirens going on and all kinds of stuff. I'm outside in my backyard right now. All right, once we're sure we've got everything completely covered, let's give it a little bit extra. You don't have to worry about the black lettering on these plastics. That does not bleach out. But the ugly brown and yellow color should bleach out and restore this to its original color. I put them inside a plastic freezer bag, like so. Just insert them in here because it's got to bleach in the sun for an hour or two. Let's put a little tiny bit of air in there. And then when we seal it up, I just lay it out on my lawn in my backyard for a couple hours in the sun for it to bleach and that peroxide to activate. And hopefully when we come back, it will have been restored to its original color. So after about 2 hours bleaching in the sun, I took the front panel in and rinsed it off completely and thoroughly dried it and reassembled the front panel onto the plug-in module and reinstalled the plug-in module in the instrument. I also used the uh, the um, the latch, the plastic latch here that was not broken from the parts donor unit. I replaced the top cover with the one from the parts donor unit, which was less gouged up and dinged up and banged up. I also added tilt stand and feet to the instrument, cleaned it outside and inside thoroughly, and I believe the cosmetic restoration is complete. I wanted to show you just how much of an improvement we made to the color of this front panel by comparing it to the other plug-in module that we did not bleach in the sun with the peroxide. That's what the other plug-in module looks like. This is almost its original color. These HP instruments are not supposed to be this color. So yeah, so the Retrobright process really worked really well, I think. All right, so the cosmetic restoration is complete, but we still have some electronic issues with this particular unit. Sometimes the instrument works just fine, and other times it does not. It seems to be working fine at this particular moment, but if we let it warm up a little bit, um, I imagine we will be able to see the problem that I have noticed. So I'm gonna just pause the camera and wait for it to start failing, and I'll start re-recording at that time. Okay, so the instrument has been on for about an hour now with a short applied across the input. So it should be reading 0 volts. And look what it's doing now. Very strange scanning of 8s across the screen. I've also noticed sometimes it scans other numbers across the screen. It's a very strange behavior. I don't really know what could be causing this. It might be, um, you know, oftentimes with these things, it's something very simple and obvious, like an electrolytic in the power supply or something like that. So that's probably what we'll take a look at first, see if we can see ripple in the power supplies or something along those lines. But it is very strange behavior. So I've removed the top cover and turned the instrument sideways so I have access to the power supply board. The power supply voltages can be measured right on the collectors, which are the cases of each of these transistors on the power supply board. So I'm going to measure them now. Plus there's a test point over here for the plus 10 volt. It measures 10.000. That's got to be good. Plus 20 volts, plus 20.04. That's good. Plus 30.07. That's good. Plus 5.17. That's good. Minus 30 volts reads negative 29.72. That's probably good. Minus 20 volts reads minus 19.99. All of them are very close except for the negative 30 volt power supply. That may be where our problem is located. I am not really sure. It's actually working right now, so the failure mode hasn't kicked in yet. This heatsink board is getting a little bit warm to the touch. Something else I noticed, um, the core of the main power transformer seems to get unusually hot. It isn't hot right now, but over time it seems to get unusually hot. And let me zoom in with the camera. I want to show you something. I don't know if you can see it with this camera, but all right, maybe you can see a little bit. If you look right here, right along here, along this crack between the power transformer and the main chassis, someone has applied some of that silicone heatsink compound to between the power transformer and the chassis. There shouldn't be any reason for that. Um, the chassis is not being used to draw heat from the power transformer core. So that means that whoever the previous owner was, they already knew that there was a problem somewhere in the power supply and that the transformer was getting way too hot. Also, if you look down here, there is a missing screw right here. And one of these screws that holds the power transformer to the chassis is also missing the nut on the back panel. It's missing the nut. So someone has most definitely been in here trying to solve the problem before. Let me disconnect the power here so that I'm safe. I've noticed something else as well. Let me zoom back out a little bit. This power supply board comes out like so. And underneath are where the main power supply capacitors are located. And apparently, someone has replaced the two capacitors that are in this dual capacitor here. I believe this is C3AB, C3A and C3B. Now they appear to be high quality capacitors. Not the best job mechanically, but I guess it's probably okay. I'm going to test them out to make sure they're all right. I'm also going to test all these other electrolytics. These can electrolytics seem to always do well and almost never seem to fail. But in this case, maybe one of them has failed. Also on the main power supply board, we have um, several of these tantalum capacitors. I'm going to check all of those too. Maybe one of those is has some leakage in it or something. They almost never go bad either, but I will check each and every single one of them. It seemed like maybe the negative 30-volt supply was a little bit low. I don't remember which one. This one, I guess. Yeah, the negative 30-volt supply was a little bit low, so I might want to take a look at that. But I have a feeling there may be a problem in the power transformer itself. But I'm going to take a look at all of those things. I'll do some sub-component testing, make sure everything checks out okay. And I might want to pull some of the boards and see if maybe some of these power supplies have been loaded down a little bit. Or I might be able to get an ammeter in here and measure the current draw on some of these supplies and take a look and see if we have anything out of the ordinary there. We get to the bottom of this. I'm almost positive it's a problem in the power supply. This power transformer should not be so warm after 30 minutes of operation. It should not be almost too hot to touch. I have noticed that it's a very slight amount of hum coming from the core of the power transformer. That may or may not be normal, but in any case, it should not be getting warm. Something else I have noticed, underneath the bottom cover, there is this PC board shield. It's a solid ground plane type circuit board, and there are supposed to be 9 screws holding it in place. There were only 3 screws holding it in place. We are missing 6 of the screws that hold this grounded shield on the bottom of the instrument. This may be my entire problem right here. I don't know. But somebody has been in here messing around and they didn't replace a lot of the hardware. So after thoroughly checking all of the capacitors in the power supply section and taking a look at diode testing all of the semiconductors in the power supply, I didn't find anything that was defective. All the capacitors are good, including these big cans. I decided I'm just going to replace the power transformer because it's not supposed to get that hot. And I have a replacement from the donor unit, so I might as well do it. Looking at the back, you can see all of that silicone heatsink compound that one of the previous owners decided would be required to remove the heat out of the core of this transformer. I believe there's probably a shorted turn in here somewhere or something. Um, the power transformer still works, but it should not heat up to that degree, and it does. So countless secondary connections had to be removed. Um, but I'm just going to swap it out and stick in the transformer from the other donor parts unit, and we'll see if that one gets hot as well. But I think this will probably resolve that issue. I don't know if it'll really solve the problem, but it will resolve that heat issue that we were having with the core of the transformer. At least I hope so. So let's do that. Well, it looks like I have jumped into the idea of swapping out the power transformer before realizing fully what I was getting myself into. Let me show you some of the observations I have found. First of all, um, this is the power transformer that heats up, and it is covered with that silicone heatsink grease. This is the one out of the parts donor unit, and I notice that it is also covered with heatsink grease. So apparently, that was a normal practice by Hewlett Packard to put heatsink grease on the frame of the power transformer. That's observation number one. Um, I didn't think that was normal, but apparently it is. Observation number two, looking at the covers, they have different part numbers. The part number is not the same. Now, I don't think the part number, in fact, I'm sure that the part number is not, does not because of a different color. That's not why they're different part numbers. Let me show you why there are different part numbers. On the original transformer, we have this extra blue pair of wires, an extra winding on this transformer. It comes out of the primary side of the transformer, but it's a secondary. All right, these are the primary wires over here. This is a secondary that goes to the isolated power supply for the BCD output, option 4 on my original units. The parts donor unit does not have option 4 installed, and therefore it does not have this blue pair of wires coming out of the primary side of the transformer. It's a secondary winding, but it comes out of the primary side on the original instrument. On the donor parts unit does not have that winding. It's a different transformer. There's no need to have a winding if there is no isolated power supply, if there's no option 4 BCD output, which the donor parts unit does not have. So if I put this transformer in, I will not have power to drive the BCD output, option 4, which is that weird DB25 or whatever it is connector on the rear panel. I think I'm going to go ahead and do it anyway. I'm not too worried about option 4, but that means that that board, which is the A5 assembly in one of the slots on the motherboard, will not have power. And I can probably just unplug that board. I have to make sure by taking a look at the schematic to make sure there's nothing else I have to do to disable that option. I'm not really interested in that BCD output connector, but we're going to put this new transformer in to replace the old transformer. That means we're giving up option 4 on the instrument, which is fine with me. I'm not going to use it anyway. But I made the decision to pull this out before I really understood the implications of my decision. So that is what the implication is. We're disabling option 4 if I put this other transformer in there. But that's my plan. So we'll see how it goes. The 4 primary wires are soldered onto the back of the line voltage selector switch, and the earth ground wire is soldered directly to the earth ground terminal at the line voltage receptacle. Then the entire input primary side is covered up with this little shield. And this shield is from the donor parts unit because the shield that was on the original unit originally had the A9 power supply board for the isolated power supply for the BCD output. We're not going to reinstall the BCD output option, so we don't need the isolated power supply board. So we're going to use the plain shield cover on the input primary side. And then the transformer can be bolted onto the rear panel using the 4 bolts that came out originally. Make sure you use the little insulating washer underneath the heads of these bolts, otherwise you will cause a short circuit in the transformer. You will create a loop that creates a shorted turn, and the transformer will overheat if you do that. So that's next. Then I have to carefully fish all these secondary windings through the hole in the rear guard shield and reattach the shield to the motherboard. And connect each color-coded secondary connection to its corresponding labeled pin on the motherboard. And I reinstalled the boards into the corresponding color-coded positions. HP, generally speaking, uses the standard resistor color codes to identify their boards. So the yellow board would be A4, the orange board would be A3, the red board would be A2, and the brown board would be A1. I am not reinstalling the A5, the green board, the A5 board, because that is only used for the BCD output option, which we are not inserting back into this instrument. We're going to leave that board out of this instrument from now on, because we don't have the isolated power supply to power that board. So there's no point in sticking the board in there. It probably just cause more problems than it solves. And put the top and bottom covers on. And then if I haven't wired anything incorrectly, we won't release any magic smoke, and we won't see any arcs and sparks. I'm just kidding. You think I would have put the top and bottom covers on if I hadn't already tested it out to be sure it's wired correctly? Here we go. All right. Now, I don't actually know if I've actually resolved the original problem. Chances are that I have not. But that power transformer, there was something wrong with it anyway. I believe it was the transformer. We'll have to see. So I'm going to let it warm up for half an hour or maybe an hour, and we'll see if we saw that strange problem with the numbers scanning across the digits. We'll have to take a look and see. It's possible we solved the problem. More likely than not that we have not solved the problem yet. So I have good news and I have bad news. The good news is I haven't made the situation worse. The bad news is the original problem still exists. So we're going to have to do some more troubleshooting. But that will have to be in the next episode, because this video is already getting way too long. So stay tuned for part 2 of the 3480B digital voltmeter restoration. Thank you very much for watching. Please like and subscribe, of course, and stay tuned for part 2.